Look at this glowing brain, sitting helpless in a sterile jar. This is exactly how the tech industry treats AI right now. Every time a new model drops, we obsess over the intelligence benchmarks, who scored higher on math or who writes a better Python function. But for actual software development, comparing raw intelligence test scores is the wrong metric. A highly intelligent AI model, on its own, cannot type on your keyboard. It cannot open a local directory, read your files, or deploy a server. It is essentially a disembodied brain. To actually do work, that brain has to snap into this, a mechanical framework. We call this the harness. It's the digital body that surrounds the AI, giving it the memory, the tools, and the environment it needs to execute a task. Right now, the two dominant AI coding tools, Anthropic's Claude Code and OpenAI's Codex, have built entirely opposed harness architectures. Developers are picking between these two based on which chat interface they like better or which model feels friendlier. But underneath the surface, the harness they adopt is secretly changing how their entire engineering team operates. Benchmarks are a distraction because they ignore the structure your code lives in. The choice between these two harnesses is a fork in the road. Once your team adopts to one, the cost of switching to the other begins to compound. Let's look at where these tools physically live, starting with Claude Code. Claude operates directly inside your terminal. It sits on your local machine and uses raw Unix commands like grep and git to freely rummage through your actual file directories, seeing everything a human developer would see. This side-by-side diagram illustrates the contrast. On the left, Claude's node is wired straight into your local file paths. On the right, OpenAI's Codex sits isolated inside a floating cloud boundary. It communicates with your laptop through a remote procedure call, meaning data only travels through a strictly gated pipe. The trade-off is stark. Claude gives you ultimate flexibility, but you are trusting it with your entire local environment. Codex trades that freedom for security, ensuring a rogue agent can never accidentally delete your hard drive. But wherever the AI lives, it still suffers from the goldfish problem. Every time you close your laptop and open a new session, the AI starts with zero memory of what you were just dumping. Claude attempts to solve this memory crisis by forcing the agent itself to remember. At the start of every session, Claude reads a persistent text document, essentially an employee handbook, that tells it exactly how your project is structured and what your coding preferences are. Codex takes the exact opposite approach. It forces the codebase itself to remember. Instead of asking the AI to read a rulebook, OpenAI relies on architectural constraints and automated linting, programs that analyze code for errors, to reject bad outputs until the AI's work matches the repository standard. Claude trusts the AI to read the rules and behave. Codex trusts the system infrastructure to force the AI into compliance. The differences become even more extreme when you scale up to massive projects that require multiple AI agents working at the same time. Notice how this architecture is structured. Claude uses a central planner node to coordinate a chatty, chaotic team of subagents. All of them share the same central data pool, meaning they can see what the others are doing. Because they share this context, these subagents can talk to each other and collaborate on creative architectural problems as a team. Now look at Codex's approach to teamwork. It puts every subagent in solitary confinement. Each node is locked inside its own isolated square, working on tasks in parallel with absolutely no lines of communication between them. Because they are isolated, these agents cannot accidentally break each other's code. You get far fewer bugs. But they lose the ability to brainstorm or piece together holistic solutions. Engineering leaders must choose between Claude's messy, creative teamwork or the sterile, highly reliable isolation you get with Codex. When you deploy one of these systems across an entire company, the consequences of those architectural choices pile up over the course of a year. Your team will start writing custom commands to speed up their workflow. You will build out extensive rule files, configure specific cloud sandboxes, and automate your testing environment to match exactly how the AI operates. Because the bodies of these two systems are so distinct, every single one of those adaptations is specific to the harness you chose. None of it can be ported to a competitor's system. This generated video illustrates the friction of migration. Moving from Claude to Codex after a year of development requires a complete demolition of your automated engineering pipeline, forcing a total rebuild of your environment from zero. You have to stop evaluating these tools based on whether they score 2 points higher on a generic math test, or whether you prefer the color of their chat interface. If your work requires deep, local exploration of a complex system, and you need an agent that can collaborate creatively, you choose the Claude harness. If your pipeline demands pristine, bug-free code executed in a highly controlled cloud environment, you choose the Codex harness. You are entering a permanent architectural marriage. Making the wrong choice today will compound into an inescapable technical debt tomorrow.